Welcome again to Bungalows for Bachelors. We need to know how we're going to resist the lateral forces that are put on our homes. Lateral forces are side to side forces, like imagine pushing on the walls sideways, or the earth moving side to side, the house shaking around side to side. Those are the lateral forces we got to resist here. So, how does our house resist some of those things structurally? Well, in this case, well, there's many ways, but in most cases, we're going to be using on the outside of the house sheathing panels. This could be plywood or OSB, and this is an example of what it would look like. Now, there would usually be a bunch of them all the way around the house, but in this case, I only put on a few to show an example of the panels themselves being in a certain spot to serve a certain purpose. So normally you would just cover the house in this and you'd be totally good to go, over designed, no problems. But I'm just showing you, here's a panel. They're usually 4 feet by 8 feet. You can buy them in 9-foot tall sections and 10-foot tall sections, and questionably up to 12-foot tall sections, maybe, depending on what product you're buying. But you can get them in taller things if you have a 9-foot ceiling or 10-foot ceiling, things like that, to make it easier to install. But the purpose of these is when they're nailed to the studs, it prevents the wall from being racked sideways. So this wall can't rack over to the right, fall over to the right, can't fall over to the left. So when the wind blows on the front of the house, tries to push the house into the screen from this view, and from this view, it's trying to push the house over to the right. These panels on these walls are going to resist that, and they're going to stiffen up the assembly and give it some strength laterally. So one of the methods is sheathing panels. Another method is a let-in brace. Let-in brace, that is the word. Usually these are going to be installed on the interior walls of a house if they're needed, and they are usually, if it's a 2x4 wall, you're going to use a 1x4. And if it's a 2x6 wall, you can use up to a 2x4, a little bit thicker. But the basic premise is you're going to actually notch out your studs and you're going to push this board into the studs and nail it on. And what it's going to do, it's going to connect all the way from the bottom plate to each stud up to the top plates. And it's going to act as the same resistance to racking motion that the sheathing panels would, but these are a lot easier to put and hide inside a wall. You don't need to put sheathing on the outside of a wall. So that's why those are better suited to the inside of a house. So some other things that we could talk about are anchor straps or anchor bolts. So sometimes we need hardware in special locations to hold things down to the house. So for this panel, for example, for this panel to not rotate to the left or rotate to the right, we need to hold down each corner depending on the design. And in that, we would do that by using what's called a hold down. It's basically a big strap that gets nailed to the stud, and it has usually a bolt and a nut that's anchored down to the concrete or anchored down to something that's part of the foundation that's very heavy. It's going to resist that. And they're going to put one on each side. I didn't draw one over here, but you'd put one on each side of the panel so that the wind could blow either direction and the panel can't rock, can't pick up off the foundation. And that's in addition to the regular anchor bolts that are going to be placed around your foundation to keep your walls bolted down to your foundation. So anchor bolts, that's what those look like. If we were to look at anchor straps, this would be an example. This is set on a form board. That's a form board for concrete. And the bottom part gets embedded in the concrete and gets stuck there. And the top part gets nailed on to the outside of the sheathing panel or the studs to secure the house down to the foundation. It's just a more heavy duty example. These are a little more complicated because you really got to make sure these are in the right spot when you pour, because if they're not, then they're poured in the wrong spot and that's a pain in the butt. So those would be anchor straps. There are some things called strong walls that Simpson Strong Tie makes that are basically shorter panels that serve the same purpose as like a sheathing panel would in terms of adding lateral stability to the wall assembly, but they're used in smaller spaces where maybe you can't fit a wide enough sheathing panel, like a 48-inch panel or 36-inch panel. You don't have space for it because there's not enough wall area. So you would put one of these in there. Now these are a little more expensive to get and to install, but if you have a design and that's the only way to do it, then that's the way to do it. You can get them pretty narrow. So that's another example of something that can be used. And occasionally you will also see, here's one drawn here. This is a portal frame. So this is a way to describe getting lateral stability out of a spot with very little wall area. I drew one on the back here, modeled it up. The basic premise is, and this was modeled fairly quickly. Ignore the fact this is not necessarily even, but the premise is if I need to get lateral stability out of a piece of wall and I can only fit some narrow panels next to my opening, then if I extend my opening header past the opening and then overlap it with a sheathing panel on the outside of the house, and then nail it together with a bunch of nails in a particular pattern, then I am basically creating one large assembly that allows myself to gain a lot of rigidity in my wall laterally. So that's called a portal frame. There are a few different kinds of those we could make. There's a bunch of drawings of them in the International Residential Code. That's where you can find those. But those are some examples of some tools we're going to use. You can also account for sheetrock. Sheetrock, when it's installed over the whole house, adds lots of lateral stability to the house. Now, normally we don't account for it because it's just kind of we like to know that our structure is going to be good based on the wood we're putting in, but it can be accounted for sometimes if we need the exception to be made. So those are some things to be familiar with